Now we need to practice drawing some of the covalent molecules. Okay? In this video, I'm going to ignore the ionic bond. How can you recognize it so quickly? Looking up the first element in the periodic table, if it lies group 1, 2, 3, just ignore it. So we are going to focus only on those molecules. Let's start. First, I have here CO2. How to draw? Draw C. First, look for a good symmetry for the molecule. Look for a central atom to put it in the middle, and then arrange your configuration. And then look up at the periodic table. You'll see that carbon has 4 electrons because it locates in group 14. So how can I arrange the 4 electrons? 2 and 2. While oxygen, which locates in group 6, and needs 2 electrons to be stable, so 2 electrons should be shared from each oxygen atom. What's left? Put them on the outside of the bond. H2O. We have 2 hydrogen, 1 oxygen, so I'll put oxygen in the middle and I'll put hydrogen on the other side. Hydrogen has 1 electron and doesn't have any other option. It should share this electron. Oxygen has 6 electron outer shell and should share 2 to be stable. So the 2 electrons will go to the 2 hydrogen atoms. In this example, H2S. It's very similar to H2O because S and O lie in the same group. So no difference at all between the bond in water and in H2S. HCl, hydrogen and Cl. Hydrogen has 1 electron that is shared, while Cl, lying group 7, has 7 electrons. It needs 1 to be stable. It will share 1 here, and 6 will be left outside the bond. C2H4. How can I organize this molecule? C2H4. Very simply, you can recognize that it should be like this. 2 carbon atoms in the middle, and each carbon will bond to 2 hydrogen. You know that hydrogen shares 1 because no other option for it. Carbon has 4 electrons in the outer shell, and it should make bond with the 3 of them. This carbon should make a bond with this carbon and the H and H. So it will share 1 electron with hydrogen, and the 2 electrons will be left here. On the other side, the carbon will share 1 electron with each hydrogen, and the 2 electrons will be left in the middle. So it's a double covalent bond. So I have here 2 single covalent bonds, 2 single covalent bonds, here 2 double covalent bonds, here 1 single, and here 1 double. Of course, there are also 4 single, you can write them. NH3, nitrogen, and 3 hydrogen. Hydrogen will share its electron. Nitrogen has 5. It's going to share 1 with each H, and the 2 will remain outside the bond. CH4 is carbon and 4 hydrogen. Hydrogen will share 1. Carbon has 4 electrons, so they will be divided equally. 1, 2, 3, and 4. 4 single covalent bond. Here, 3 single covalent bonds. Thank you, my dear students, for your listening. I hope you understood the lesson. Goodbye. My dear student, good morning. In this tutorial, I will discuss with you the covalent bond. Remember, in the first video, we explained the ionic bond. Covalent bond is a bond which is formed between two or more non-metal atoms by equal sharing of electrons. So very simply, we can define covalent bond as equal share of valence electrons between two or more non-metal atoms. Let's go into more details about the covalent bond formation. Looking at the periodic table, you will distinguish the metals from non-metals. As we have said before, metals occupy mostly groups 1 and 2 and transition metals that occupy the middle of the table. Group 3, it includes either metals or metallides. So also they are not or never be considered as non-metals. Here are the boundary between metals and the non-metals in the periodic table. All of those elements are metals. So they are not involved in formation of covalent bond. While hydrogen, in addition to the elements on the right-hand sides, those elements can be involved in formation of covalent bonding. Remember that the group number indicates or gives us an evidence for the number of electrons in the outer shell, or what we say valence electrons. So hydrogen here has 1 valence electrons. Elements in group 2 has 2 valence electrons, 3, 4, 5, 6, 7, and 8. Except helium, which has only 2 electrons instead of 8. So the element which lies in group 4, like carbon, has 4 electrons in outer shell. In order to be stable, it should share 4 more electrons to reach the structure of the next noble gas. Because C, it has 4 electrons. If it gains 1, 2, 3, 4, it will reach the structure of the noble gas. So we say that the valency of carbon is 4. Hydrogen. Hydrogen is in group 1. So hydrogen does need only to share 1 electron to reach the structure of the next noble gas, which is helium. So the valence of hydrogen is 1. 3. Cl. Valency of Cl. You can guess it. Cl lies in group 17 and has 7 electrons, as you can see. So it does have only 1 electron to gain to reach the structure of the next noble gas. This means that the valence of Cl is 1. The last example, let's look for sulfur. Valency of S is sulfur lies in group 16 and does have 6 electrons in outer shell. How many electrons does it need to gain or share to be noble or to reach the configuration of a noble gas? 1, 2. So the valency of sulfur is 2. Now we need to explain how covalent bond is formed. Covalent bond formation. Let's take an example, H and Cl. Hydrogen has 1 electron in the outer shell, while Cl has 7 electrons in the outer shell. Both of those elements need to gain 1 electron to be stable, as we have just said, or share 1 electron. So Each of those elements will share one electron. 1, 2, 3, 4, 5, 6. And what one will be shared? Hydrogen also will share one electron. So we have equal share of one electron between each atom. This kind of bond, we call it single covalent bond because only one electron has been shared from each atom, or it does have only one pair of electrons. Single covalent bond, one pair of shared electrons. Also, you can show that by drawing, by writing HCl. So the single covalent bond. Another example, hydrogen and sulfur. Sulfur lies in group 6 and has 6 electrons in outer shell. Hydrogen has only 1. Hydrogen should share only 1 electron in the bond. So hydrogen will share 1 electron in the bond. On the other hand, S has 6 electrons, 1, 2, 3, 4, 5, 6. So it needs to share 2 electrons. It's going to share 1 electron here with hydrogen. And what about the second electron? So the second electron should be shared with another hydrogen atom. So we should use here 2 hydrogen atoms. Sulfur share 1 with either of the 2 hydrogen atoms. Share 1 on that side and share 1 on the other side. Now sulfur became stable as it becomes an octet now. Octet means it does have 8 electrons in the outer shell. Let's count 1, 2, 3, 4, 5, 6, 7, 8. Also, we can represent this by this drawing to show that I have here 2 single covalent bonding. Now let me stress on the naming of the compound. We don't change the name of the first compound, while the second one should be changed. So if hydrogen reacts with Cl, we call it hydrogen chloride. If hydrogen reacts with sulfur, we call the compound hydrogen disulfide. I have 2 sulfur here. Nitrogen trihydride, or the common name for this compound is ammonia. Hydrogen chloride, hydrogen sulfide, or you can say disulfide. In some curriculum, it's accepted. Here, nitrogen trihydride, but the common name is ammonia. In this example, the bond will be formed between hydrogen and carbon. Remember that carbon locates in group 4 and has 4 electrons in outer shell and should share 4 electrons, while hydrogen can share only 1. That's why we should use 4 hydrogen atoms. Each of them is going to share 1 electron in the bond. So C now will bond to 4 hydrogen atom via 4 single covalent bond. Don't forget to show the electron pair which is shared between the atoms. And you can draw it like this as a simplified drawing. Also, the name of this compound is carbon tetrahydride, or the common name is methane. There are other kinds of covalent bonds where each atom shares two electrons, or one atom at least shares two electrons. We call those kinds of bonding double covalent bonding. Double covalent bonding. In double covalent bond, each atom shares two electrons. We have an example here, O2, O and O. Each oxygen atom has 6 electrons in the outer shell. In order to be stable, each atom should share 2 electrons. So the first atom will share 2, the second atom will share 2. This means that in the bond region, we call this region bond region. In the bond region, we have 2 pairs of electrons. That's why we call it double covalent bond. 6. Carbon dioxide. It made of 1 carbon and 2 oxygen atoms. Carbon has 4 electrons in the outer shell. 4 electrons. So in order to be stable, it needs to share 4 electrons, right? This means that we are going to remove those electrons from here and we'll put them on the other hand here on that side. Each carbon here shares 2 electrons. Oxygen also should share 2 electrons. Oxygen, as we have just said, it has 6 electrons in the outer shell. To be stable, it will share 2 electrons, and the 4 will be left out. 2 are shared and 4 are left out. So now carbon atom has 2 double covalent bonds. 2 double covalent bonds. Third type of covalent bond, we call it triple covalent bond. In triple covalent bond, each atom, or one atom at least, shares 3 electrons in the bond. The common example here is N2. Nitrogen locates in group 5 and has 5 electrons in outer shell. So each nitrogen atom needs to share 3 electrons. This atom will share 3 and the other atom will share also 3. So in the bond, 3 electrons will be shared from each atom and 2 will be left out. So inside the bond, we have triple covalent bond between the 2 nitrogen atoms. 6 electrons are there. So it's a 1 triple covalent bond. This is nitrogen gas.